the module 2 is regarding the groundwater. Module 1 is completely regarding with the rainfall. Now, before understanding the groundwater, you should understand a name. So, without this name, you cannot imagine the groundwater. What is that name is? Aquifer. So, this is the key component. Depend on this, the groundwater changes according to the place. The aquifer decides that how much of water is available inside the soil. In the sense, everybody know that the ice can be crushed, and this they will give you a cola. I hope everybody have this experience of having this cola, isn't it? So there will be a crushed ice. In that they will dip with the sauce some color additives they will add. So you can drink it. This is called an aquifer. Like this, inside the soil you have water. The concept related to groundwater is below the soil you have this kind of water. When you are boring it, you are taking out of all the water. So this is called a concept of groundwater. Below the ground you don't have a well. You are not having any river. But you have the concept of this aquifer. What do you mean by that is, in between the soil pores, you will be having water particles. Those water particles are taken out as groundwater. The aquifer is a water bearing strata. Does all the ground is called an aquifer? No. If you have water inside the ground, then it is called aquifer. If there is no water inside the ground, then it should be called as a rock. Do you understand the difference? This is the difference. This depends upon the different types of soil. Now, can you list it out? How many types of soil you can remember? Types of soil. Sand is a type of soil. Then clay is a type of soil. Mud. Mud is kind of a loam. It is a type of soil. Then black soil you have, red soil, etc. Do you think that if a clay is holding some water, does the same amount of water is holded by sand? No. Everybody have an experience of having mudde and along with the sambar. Mudde will take more amount of sambar than if you put in rice. You would have pouring the amount of sambar, it will keep on be observing. This is called an example for clay. It will not give away that water quickly. If you compare the rice, you put rasam above the rice, it will drain off quickly. This is an example of sand. Sir, I am living with a place nearby sand. I am going to bore now. Will I have more water or less water? With the property of soil itself, you can say that how much water you will get. If you have a sandy soil, note that recharge will be very quick. That means soon as the rain comes, the water will be penetrating inside because of sand. Quickly the water will absorb. You can take it out. Sand has a quality of 30% retention. If water is poured in the sand, it can hold only 30% of water. Rest of the 70% you cannot compact. In place of clay, clay can hold 50% of water. That means, sir, if I take 1 kg of clay, I can put half kg of water and completely it will penetrate. Do you understand? That is why they are making pots. Pots with the clay, no? It will take more water. What is the disadvantage of clay is, clay will not leave the water. You can try it, nobody can straw the clay. Nothing will come. If you straw the sand, something will come. If you are having a clay soil, you don't have a groundwater. You cannot extract it. There will be some water, but you cannot extract. And water bearing formations will be there. This I will discuss in further slides. Now in this one table, you can completely understand that, sir, I am buying a land. If my land has what type of soil, then I will have a good water supply throughout my life. Gravel has porosity. You take 2 amount of sand. In between that sand, if you have a gap, then it is called pores. If you have more pores, more water can be contained in that. You understand this? Gravel has 30 to 40% of porosity. Now you can understand with this example. Do you see this is gravel and this is sand? What is the difference you are observing here? Gravel size is much higher, sand size is much lesser. You understand that when you should say gravel, if the size is higher, then it is called a gravel. If the size is smaller, it should be called as a sand. This is a technical phenomena. There is a for that. This is not required currently. Which can hold more water? You see, gravel can handle 30 to 40%, but sand can handle 35 to 40%. If you pour water in it, which holds more water? By this you can say, sand holds more water. If you are boring wherever you have sand, you will get more groundwater. Do you understand? Sand can hold more water. This is a holding capacity. Next thing is called yield. What do you mean by yield is, sir, now the sand is having water. How much I can take? How much I can take is, in gravel you can take 15 to 30%. I only have 40% maximum. In that I can take only 30%. This gravel will not leave 10% of water. Even though if you bore also, it will not give. The sand will give 10 to 30% of water. 15 to 30%, this have 10 to 30%. So this is amount of water and this is amount of yield, how much you can take. Now you take next two things. Sandstone. Have you heard about sandstone? Sandstone is like this. Nearby a quarry, these are all called sandstones. Have you seen there will be a waterlogged area nearby the sandstone? Have you seen this? Nearby some quarrying place, you can see blue color of water. Who poured water inside that? Have you questioned? These answers you can get it from here. Wherever you see this kind of mining place, if you have some water, drop it above that, it will penetrate inside. That is called sandstone. From the name itself, you can understand that sandstone is, you have a concept of weathering. So even though you have sand, after few years, it will become so hard and it will become rock. Not all the sands will not be a sand till the end. So it becomes as a rock. That is why it is called sandstone. In the sandstone, if you pour water, it will penetrate inside. But if you pour water in granite or rock, it will not penetrate. It will be there at the top. That is why not all rocks are same. You see that these are all sandstones. If you pour water, it will drain inside, but not quickly. You see, sandstone have 10 to 30% of water will be there. Even though it might be seen as a rock, if you bore it, you might have 10 to 30% of yield, but the water will not come. You see that in sand 30% you can observe, but in sandstone only 50% can be observed. Now you take an example of clay. Sir, clay can take how much water in the sense? 45 to 50% of water. Sir, if I have a clay soil, I am getting plenty of rainfall in my place. But even though I am boring, I am not at all getting water. Why? Because you see the yield of clay is how much? 1 to 10%. Clay will not give. The parents, when they are scolding you, they will say it as, is your brain is made up of clay. Why? Because even though you have heard many things, you are not giving up. Do you see the property of clay? Clay can hold more water, but it cannot give more water. That is the property, is called yield. So even though it has highest number of porosity, it will not give. Next thing is limestone and shale. These are all rocks. These rocks have less porosity and specific yield is very less. An example of the limestone. Have you seen this kind of caves? The limestone will have a aquifer. That means water holding capacity is there. This is an example of limestone and this is an example of shale. Have you seen in India, you visit this kind of places, this is available in Deccan Plateau place, Deccan Plateau regions. You see this kind of rock doesn't have a yield. That means if you are boring, you will not get water in these places. Next thing, different kind of soils are there. What are they? Clay, loam, sand and silt. This is depending on the size. So clay will be very less in size you cannot take 1 grain of a clay, but you can take 1 grain of a sand. So this is the example. Very coarse sand. How much ml of water will be there? You can see here. Out of 300 mm of soil, coarse sand only has 10 to 20. You cannot pour more water. Out of 300 mm, 300 mm is 1 feet scale. Within that, if rainfall comes, how much water it can hold? 10 to 20 mm of water only it can hold. More than that it cannot hold. Clay can hold up to 40 to 65 mm of water. Out of 300 mm, you divide 65 divided by 300, that is 21 percentage. Clay can hold 21 percentage of water. This much of water it can hold. Next thing, key characteristics of aquifer. So I told that water holding capacity, below the ground you have different layers. There are two types of aquifer. First type is unconfined aquifer. What do you mean by unconfined is, you will be having a land surface like this, you will be having a stream. If you dig some soil here, the water will automatically come up. Unconfined aquifers are upper surface, which is generally nearby water table. How much water it can hold? 10 to 30 percentage of water it can hold. Next thing is confined aquifers. Above and below of that, you will be having an impermeable strata. Don't think that all the soils are permeable. Below the soil, there might be impermeability also. Storability of confined aquifers is 0.1 to 1% only. So, which aquifer has more water? Unconfined. Unconfined has how much water? 10 to 30%. But unconfined have how much water? 0.1 to 1% of water alone. Have you seen this kind of image, this kind of place where the water is coming inside the hill? We saw that valleys are, the water will be flowing above the hill. Here the water is flowing inside the hill. Have you seen this kind of place? This exists. What is the reason of this is, which we are studying now. Don't think that water will always come up to down. Water will come in between the soil. This is an example of aquifers. What will happen? During a rainfall, the water will keep on be penetrating inside. This holding capacity will be drained here. Wherever you have a hole, by this hole the water will get drained. Due to this, you will be getting a valley. So this is an example of this. Majorly, if you are studying two important properties of groundwater. One thing is porosity, next one is permeability. What do you mean by porosity is, this is an example. By this three example, you can find that what do you mean by non-porous. That means if any water you put here, the water will not go inside because the two sand particles are very close. The water cannot go inside here. This is an example of shale. I have told different types of soil, no? Shale, granite, rocks. Why the water is not going in the sense? The particles are so tight. It is non-porous or non-permeable. You don't have a gap and the water cannot go. Second thing is closed porosity. What do you mean by closed porosity is? Can you see there is a gap here? The water cannot go inside. But whatever water is already there will be existing. This is called porous impermeable. Next thing, interconnected porosity, porous and permeable. That means what? This is a kind of place where the water can penetrate inside. Which type of soil available in earth? All the three types of soil is available in the earth. So this is an example of rock, non-porous, non-permeable. You take a glass, you pour some water on the glass. Will the water penetrate inside the glass? No, this is called non-porous. How much ever water you put in a glass, it will not penetrate inside. Take a second example. You have a wood. Now you pour water above the wood. Will the water penetrate inside? Yes, you can see some dampness. It will not go quickly. but you can see some dampness. What do you mean by dampness? There will be a water patches, yes or no? So that is the example of porous and impermeable. You take a sponge, then you pour water. Will it go inside? Definitely it will go. What is the difference between these three? Glass is an example of non-porous, non-permeable. Then this is an example of what? Wood. Wood is an example of closed porosity, porous, permeable. Then this is an example of sponge. If you put some water in the sponge, it can penetrate inside and it can come. But if you take a wood, will the water penetrate and come at the bottom? No. This is the difference. So three types of soils are existing in the earth. Now these are the two major property, porosity and permeability. Next thing is recharge and discharge. I have heard about springs and wells. I have told with the example also. Spring. Sir, in between a rock, if there is water coming, then it is called what? Spring. I have told Kaveri example, no? In between small rocks, some water is coming there, that is called spring. So, due to that, springs and well, rivers, etc. are the part of aquifers. This is an example of that. Have you seen anywhere like this? The water is flowing outside the well. This is a well. They have drived somewhere. The water is coming outside the well. This is called artesian well. It is called flowing well. Wherever you see this kind of place, you buy the land quickly. Why? Because you will not at all have a scarcity of water. You can do agricultural land. Sir, I am going to purchase an agricultural land. Don't think only for construction of house. Sir, I am going to purchase land for agriculture. For agriculture, what is required? Water. You take a place where you have shale, where you have granite. You are trying for agriculture in the sense, you will be a poor farmer. Your money will vanish. If you are purchasing a land where you have an artesian well, you buy that land quickly. Whatever you sow, you will get plenty of water. You can make profit out of it. Even though you can do agricultural engineering, how to do successfully. These are all the things you should know. Sir, why I am studying here is, tomorrow you can do a good agricultural project. I told number of sensors are there. By using sensors, connectivity, you can automatically monitor the agriculture. No humans are required. Only with electronics, with internet connectivity, you can do agriculture. For that, you should need this. Do you understand? Don't plan a agricultural place if you don't have this kind of property. So this is a place where you have well. Sir, I am purchasing a land that has a well. Check that what is the depth of water in the well. If the water is available more than 100 feet, don't buy it. Why? Because after draining it, it will not get recharged quickly. Sir, I am having a water in 50 feet, 25 feet. Or this kind of artesian wells, you buy that land quickly. With minimum amount, you can get more benefit. This you should know what is aquifers and artesian wells. In India, throughout India, what are the types of soil is there? I have given soils from clay, gravel, then sand, shale, limestone, sandstone. These things I have discussed. Now in India, what are the types of soil available? This is a place where you have Indo-Gangetic plain. Throughout this place, can you see Rajasthan here? In 28% they are performing throughout India. They are doing good. How in the sense? What kind of soil they have? Alluvial aquifers. What do you mean by alluvial aquifers, sir? It can hold more water. Sir, the Rajasthan, how it is doing a good agriculture in the sense, their soil. What kind of soil is there in Rajasthan? Alluvial aquifers and alluvial soils you have composed of what? Sand, silt and gravel. Rajasthan places will be light brown in color wherever you see. it will be light brown and more dust will be there. So you can see more water will be there. How much alluvial soil can hold is 55 to 65% of water. That is why they get more amount of groundwater. Best groundwater potentials in India. See the nature making someone not to get certain things. Some students will be there, sir, I am putting more effort but my mark is not coming. My friend is only studying for 1 hour, 2 hour, he is getting more mark. Sir, I am studying and getting first mark. After 20 years, I am still a salaried person. The person's father is very good. After 20 years, he became a businessman. Nature at one part will be very angel kind of a character. In other part, it will be like a very harsh character. Like that, Rajasthan doesn't have good rainfall. But what does it have? Soil. What soil they have? Alluvial soil. Alluvial soil holds